Assalamu alaikum. My name is Ammar AlSaleh. This is a project demonstration at King Fahd University of Petroleum and Minerals for the graduate course COE 546 Computer Network Design under the supervision of Dr. Tariq Sheltami. Our team members are me, Ammar AlSaleh, and Saud, Mohammad, Mostafa, and Aziz, Abdul Ghaffar. I will go through the introduction, problem statement, proposed solution, and finally implementation and results. Internet of Things is a collection of smart devices that are connected to each other and exchange data through the internet. IoT is a new technology that enhances different industries and services, and healthcare services can benefit from it. IoT has the potential to not only keep patients safe and healthy, but to improve how doctors deliver care as well. Better health is central to human happiness and well-being. Medical field scientists are looking for improvements to people's health. It also makes an important contribution to economic progress, as healthy populations live longer and are more productive. Our problem statement: multiple diseases needed to be regularly checked and monitored at the hospital. We have about 12.8% and 5% of all deaths is caused by hypertension and chronic obstructive pulmonary diseases, COPD, respectively. Glaucoma is the second leading cause of blindness worldwide. Present healthcare system require patients to either visit hospitals physically for a checkup or to get an appointment from a doctor. Some patients with these kind of diseases have difficulties going back and forth to the hospital. Applying IoT in the medical field will solve this problem. Our solution is focusing on hypertension, glaucoma, and chronic obstructive pulmonary disease, COPD. Our solution is divided into two parts. First, data acquisition and processing, where data is gathered from the patient using medical devices and then sent wirelessly to the healthcare center for processing. Second, we have the services, which is offered by the healthcare system. We have disease diagnosis, medicine reminder, medicine dose adjustment, appointment registration, emergency, and finally data survey and analysis. Now we will demonstrate our implementation and results through Packet Tracer simulator, which is developed by CISCO.
So regarding the implementation and results, this is our system architecture, where it includes the 3 homes, 3 patients having 3 different diseases, and there would be internet cluster or internet where it's connected with the homes, and there's a healthcare system and a mobile user. Let's start with the healthcare system. So the healthcare system has mainly consists of the research center as well as the healthcare monitoring center, which the monitoring center is basically used for monitoring the patients, and the health research center is used to gather data for study purposes. And it also has a doctor and emergency services, and it has a mail server to gather the emails and receive emails mainly from the patients and everything. Okay, and the internet is basically the DNS server and the webmail server, which will be used by the patients. And we go back and we see that the mobile user would be mainly the patient's relative who are moving at the time, and There is a group of, for study purposes, we have a group of smoker and a non-smoker whose readings will be taken for study purposes. Okay, now we'll head into one of the patient's home. So at first, this patient we are considering it's a glaucoma patient. So in the glaucoma patient, so in this environment, you see the patient has a laptop, and as well as it has a status screen as well as a diagnose and dose screen, and this is the instrument medical device which is used for measuring the uh, interocular pressure for the patient. So at first we're seeing that this is normal with no glaucoma. So we'll start with using the device, and if we increase the pressure, so now we are in the diagnosing state where it's diagnosing the patient. I mean, after the readings are sent to the healthcare system, it's checking the readings and then it will send how much. So you can see that the patient is in glaucoma, so the disease category is glaucoma and the dose required is 1 drop. And for this, the patient is then receives a reminder that you need to take 1 drop of Zalatan is actually a medicine for glaucoma. So this is what is required, and even the doctor's side, you can see that it has received a status for the patient, having that it has glaucoma and it is like 26 mmHg, and it needs 1 drop of glaucoma. So the doctor even receives after when the patient is measuring, so the doctor even receives the status as well. Okay, now we will move on to another patient just to see how it will be. Okay, so we'll come next to the hypoxic patient. So as well we have to simulate the like glaucoma will simulate the thing. So we'll decrease the oxygen level for this patient basically. So now you can see there's like use nebulizer, so it's the 87%, which is lower than the normal person's oxygen saturation level. So the recommended thing is to use a nebulizer from the healthcare system. So if we use the nebulizer, you can see the patient came back to the normal 92% oxygen saturation level. Also, if you see that if you have a patient which will go to the critical state and he goes in severe hypoxic state, then you can see that the message will be displayed as the ambulance is on the way. So the healthcare system would be shown that the oxygen status or the oxygen saturation level is below the normal state and is in the critical state, and ambulance must be dispatched immediately. So this is the emergency state. Now we go to another patient. Sorry. So this patient is a hypertension patient. So basically it has BP which would be higher than normal. Let's say we will put in the diagnosed state and we will increase its BP to stage 2 hypertension. And we have even the diagnosis has even a time, and then we are setting as that it will take some hours to do it. So diagnosis is specified by the healthcare system to send the results back. So over here it's like 10 seconds, but it will be actually 10 hours or something. So this is another thing we have assumed in our simulation. And so it's in stage 2. So and it's saying that it needs 100 milligram of the medicine dose. So now after that we will inject the dose. Now after injection, you can see it still remains in the stage 1. It does not go back to the normal level, and therefore the dose has been increased or it has been adjusted to what the patient needs. So that's why we will, and this will be received, this dose adjustment has also been received by the doctor, that the new dose is 120 mg. So now the patient even gets this, and he knows that it needs 120 mg of the medicine. So then now it will inject, and now you can see that it has gotten to normal level. And basically when the patient, when it was in stage 2, basically then it has received the patient's relative has received the appointment that please come and visit the doctor. So this you can check over here. Okay. We'll put we'll put the patient back in normal state first. Alright, now after this, now this is in the normal state. Now again we'll put it back to stage 2. This is the old one, so we can delete it. So this is stage 2, it's in hypertension stage. Received, you can see it has received. You see the time, you can even see that it's almost the same. So it's like please come for an appointment. So the patient's relative even gets another one to come for an appointment with the doctor. These are the stuffs for the patient's home, and the mobile user. So the relative is on the way, so that's what we have shown you already. So that's pretty much it. And the healthcare system, you can see over here we are showing in the monitoring that all the patients' status are given one by one. Periodically it's been shown that the mic is 82, ambulance is on the way, one is hypertension, and you can see here. So glaucoma showed in one, it's in glaucoma and has one dose. And then we can see that Mike is in severe hypoxic, and we already dispatched an ambulance for it. And Tom is in hypertension stage 2, and he needs 100 milligrams. So, and in the research center, it's actually showing the ID what we have shown here, the mobile user, the smoker and non-smoker. This is sending their readings. So it has been shown in this that it's getting one of them is ID1, having 1 age, hours and times and everything. So that's pretty much it. Thank you all.